Alright, so for this exercise, 441, it's asking us to see, does the cost of a flight depend on the distance? And here we've gathered data. We tried to find the lowest cost flight between two cities, or actually from Boston to different cities, Boston to New York, Boston to Chicago, Boston to San Francisco. And we tried to find the cheapest flight, and we also looked at how many miles the flight would be. Okay? And so in this case, we're going to load the data, once again from a web address. We're going to enter it right there. This time, you need to change the delimiter from white space to tab, okay? Because some of the cities, like San Francisco or St. Louis or whatever, they've got a space in the name of the city, so you have to change the delimiter to a tab. And so go ahead and click Load File. And when you do that, you should have the data just like this. And we can see we're looking at the cost and we're looking at the miles. And what we want to do is we want to predict the cost of a flight based on how many miles the flight is. Now, whenever we're trying to create a regression line, we first have to ask, is linear regression appropriate? Is it appropriate to use linear regression? Does a straight line relationship explain the relationship? So to do that, first we have to create a scatter plot. So we're going to go to Graphics, then Scatter Plot. And again, the x variable is our predictor, what we are using to predict. So that's going to be miles, and our y variable is going to be cost. That's our response. We are using mileage to make a prediction about cost. Okay, we just want points. You can leave all the defaults. Click Create Graph, and here are the dots for the different flights. And we can see, in general, it looks like there's an increasing trend, that as the number of miles traveled increases, the cost of the flight also seems to increase. Okay, so this does seem to be a trend, and it doesn't seem like there's a whole lot of curvature. It seems like a straight line would be okay. So include you can include a scatter plot in your work, but somewhere in there you can say, we created a scatter plot to see the relationship between mileage and cost of the flight. A straight line relationship seems appropriate, so we can continue with linear regression. So again, if you see a striking curve or something like that, linear regression is not appropriate because it's only good for straight line relationships. So then to calculate the linear regression, we're going to go down, we're going to look at our stat menu, go to regression, and do simple linear regression. Okay, and here again, our x variable, we are going to plug in miles to make a prediction for cost. So miles is our predictor and cost is our response. You can leave all of these things at the default for now, and we are going to plot the fitted line right there. Okay, leave the other ones blank, that's fine. And then we click Calculate, and this is our result. We can see the linear regression equation produced right there. So it says cost is equal to 162 plus 0.07957,149 times miles. Okay, so I'm going to write StatCrunch has produced a linear regression equation for us. It is, and it's the cost is equal to that, and so we want to just we want to make an interpretation for this. Okay, so let's talk about the slope. Okay, so here the slope is 0.079. I'm going to just round off to 6. Okay, and so here this is we are looking at the cost in dollars and the slope is attached to the variable miles. So this means that for every additional mile in the flight, so for flights that are longer by 1 mile, okay, we expect the cost of the flight on average to increase by $0.0795, okay? Or in other words, about 8 cents. We expect flights to increase about 8 cents for each additional mile, okay? And then the intercept is 162.595, so I'll just round off to 162.60. This would be our prediction for the cost of a flight that is 0 miles, okay? So it doesn't quite make sense to have a flight that's 0 miles, but you know, this could be could give us an idea of how much maybe some of the just basic costs associated with flying could be, okay? How much, yeah, the costs associated with flying are, okay? But again, it does not make sense to use to make a prediction for a flight that is 0 miles. Alright. And then the last thing that you're supposed to do is to make a prediction for a flight that is 500 miles in length. Okay? So one way is we can, our prediction for a flight that is 500 miles in length is, and what you need to do here is you need to plug in 500, and you do 500 times the mileage, 0.07957, whatever, okay? And then add that, whatever you get there, add that to 162.5956, okay? That will give you an answer. You can plug that into your calculator and solve it yourself. Another option you can do is you can actually have StatCrunch create the prediction for you. So if you go back to StatCrunch, under Options, go back to Edit, and click back through. Leave everything the same, but one of your options is to predict y for x equals something. So we're going to plug in 500 for x, that's going to be the length of the flight, and we're going to make a prediction for y. Go ahead and just leave the level that's associated with the level of confidence. We won't worry about that now, but we can leave that there. And at the bottom you can see predicted values, and we've got x value 500, predicted y 202.38. So if you did all of the math over here, our predicted y, predicted cost, is going to be $202.38. Okay, that's how much we predict a flight that is 500 miles to be. Okay. Other things you might want to also mention, the R correlation coefficient, or the R squared value, okay, 0.765. So that gives you an idea of how strong of a relationship is. Okay, so not as strong as something that's like 90 or 95%, but 76 is still pretty good correlation. The R squared is your coefficient of determination, and in this case it's 0.585, and so that would say things like about 58 or 59% of the variation in cost is explained by the variation in the mileage. Okay, so just add a couple more sentences to your lab here.